Today we'll be finding the equation of a line. So the learning intentions for today's lesson is to determine the equation of a line using its standard forms. So standard forms, we're talking about gradient intercept and another form called the general form. Okay, so these are your standard forms, so the basic ways that you would usually write out an equation. And we're going to be looking at a couple of things with how we can work out these equations. So by the end of this lesson, you should be able to determine equations of horizontal and vertical lines. And also, if you were given the equation, you should be you will know how to graph them. Other things that you will be looking at is determining the equation of a line in gradient intercept form. Okay, and that's the words that we've used up here. Or the other thing that we're going to look at is a new type of formula called the point gradient formula. Okay, so when we start moving into year 11 work, what you'll see is the point gradient formula is actually the more useful one compared to the gradient intercept form. So let's get started. So when we're looking at horizontal and vertical lines, if we're looking for a horizontal line, which is a line going in this direction, it's got the form y equals to c. So if I look at any horizontal line on a number plane, and I were to find all those coordinates of all the dots on that line, what you'll see is the thing that's the same in all of them is the y value. So the x value will change, but the y value stays constant. So that's why we've got the equation y equals to c. Vertical lines are the other way. So if I've got a number plane and I pick any point on a vertical line, the thing that they'll all share is the x coordinate. So that's why we have x equals to c. Okay, and c is just any number that will fit on a number plane. So let's have a look at these questions here. The first one, we're looking at x equals to 2. So that's going to be a vertical line passing through 2. So basically, we can just draw in a vertical line here and label it x equals to 2. When we're looking at y equals to -1, then we want a horizontal line passing through -1. So it's going to be a line passing through like so. I will label it y equals to -1. The next line we've got is what x equals to -1.5, so we can have decimals as well. Okay, so what we know is we want the value that's halfway between -1 and -2, so that's -1.5. So we can draw a line in here. So that's going to be the line x equals to -1.5. The last line that we want to draw, we just code that. The last line we want to draw is y equals to 3. Now 3 is going to be up here if we measured everything out evenly. So if we draw a horizontal line there, that's a line y equals to 3. So that's your horizontal and vertical lines. Now moving on, we're looking at if we have a sloping line. So rather than horizontal and vertical, we're looking at lines that have some gradient on it. And the gradient intercept form is the one that you should be familiar with. So if we know the gradient value, and we use m for that abbreviation, and the y-intercept, and we use c for that, then the equation of the line is written as y equals to mx plus c. So I know your textbook and some of your older work, we may have used b. It means the same thing. It doesn't really matter which letter you use, but what you find is with the new senior syllabuses, they all use C as the y-intercept. Okay, so that's sort of why we're using it more now. The other type of equation that the other type of formula we can use to find the equation of a line is called point gradient form. So gradient intercept is well and good if we know what the gradient is and we can read off a y-intercept value. But more often than not, you might be just given a point somewhere on the line. So if I have a point and then the gradient, I can use this in order to work out what the equation of the line is. And it's a little bit faster, a little bit easier. So given that gradient is m, and we give a point on the line the coordinates x1, y1, then the equation of the line we can write as y minus y1 equals mx minus x1. So that's the point gradient form of a line. When we're working with point gradient though, we can't leave our answer like this after we've done our substitutions. So when we go to write out our solution, we need to write it either in gradient intercept form or that other special form that I mentioned before called the general form. So the general form is the equation ax plus by plus c equals 0. Okay, so basically we put all of the values on the same side of the equals and then the other side is 0. And the key thing in general form is A, B, and C are all whole numbers. So we don't want any decimals, don't want any fractions. In actual fact, with the x value, we try to keep that positive as well. Okay, so A needs to be a positive value and A, B, and C are all integers. Okay, so that's sort of what we're aiming for. So if we start with point gradient, what we may need to do is expand out the gradient and then simplify. Okay, so we can either go into y equals mx plus c form, or we can use this format. Often what I will do is if I do get fractions for my gradient or my y-intercept values, I do prefer to write things in general form. It just means that we don't have fractions in our answer, and it's a little bit easier to read because of that. So when we're looking for the equation of a line, we can just use y equals mx plus c, okay, as you've done before, and that's perfectly fine. But sometimes point gradient actually provides a much easier solution for you. And I'll show you in a moment an example that I've done in using both methods. So let's have a look at these examples here. So the first one, we want to find the equation of the following lines. So in order to start this, for each of these, we want to first work out what the gradient is. So what we can do is, in our first diagram, what we can do is we want to draw out a right-angled triangle, and then we need to work out the gradient of that. So the horizontal is 2, the vertical is 5. So when I'm looking for the gradient, it's rise over run. We can see it's going upwards from left to right, so it's a positive 5 over 2. So that's the value of our gradient. The y-intercept we can also read off this equation. The y-intercept is 5. So simply when we go to write this into an equation, we're using y equals mx plus c. So if I substitute the gradient and the y-intercept in, we've got 5 over 2x plus 5. And that's going to be the equation of the line that you've got there. For question B, we've got our line and we've got 2 points on it. Now I've got the x-intercept and also another point that's on the line. So what we need to do is we need to work out the gradient by doing a rise over run. So we've got our right-angled triangle there. We need to work out how much we've gone down by. So we've started at 3, coordinate here is 3, 0. And we've moved down, the y value is going down to 2. Okay, so it's gone 2 units down. And then we've started at 3 for your x coordinates, your x values. And we're moving to 5, so the horizontal is also going to be 2. When we go to work out the gradient, it's rise over run, but this time the line's sloping downwards from left to right. So it's going to be minus 2 over 2, well, that's going to be the equation, the gradient of negative 1. Now, if we were to use y equals mx plus c, we don't know what the y-intercept is. Okay, so we can't fill in the c value yet. So what we can do is we can first write out mx plus c, and what we can do is we can substitute 1 into there first. So it'll be y equals to negative x plus c. What we know from here is that these 2 points, 3, 0 and 5, negative 2, they both will lie on the line. So what we can do is we can pick one of those coordinates. If we substitute it into this equation, then the left and the right hand side should be the same. So the equation should be true. And we can use that idea in order to work out the value of c. So what I'm going to do is I'm going to substitute in the x-intercept. Just makes it easier because we're putting in a y equals 0. So we're going to sub x equals 3, y equals 0 into the equation. So we get 0 equals to negative 3 plus c. So c is equal to 3. Now that we've got our c value, we can now put it back into our original equation, and then we've got our answer. Y equals to negative x plus 3. Okay, and that's our final answer. Now, there was a fair bit of working because you had to do substitutions there. So instead of that, what we have is that point gradient formula. So I'm going to run that out, and I'm going to do this again using the point gradient formula. What we've got here is we've got our gradient, negative 2 over 2, or negative 1. What I'm going to now do is substitute that and the point 3, 0, so that's going to be x1, y1, into the point gradient formula. So y minus y1 equals m bracket x minus x1. So our y1 value was 0, so y minus 0 equals negative 1 bracket x minus 3. From there, what we're going to do is expand the negative 1 through. So y equals negative x plus 3, which is actually exactly the same answer as what we got before. So what you find is when we're using the point gradient formula, we don't need to do as much solving or substituting. Basically, once we've put the point and the y-intercept, point and the gradient into the formula, all we need to then do is rearrange the formula to make things work. So it's a much easier way compared to using the gradient intercept form if we don't have the y-intercept. All right, let's keep going. With the next one, we've got a line with a gradient of 2, so that's your m value, and a y-intercept is 3, so that's c. You've got all that information straight away, so y equals mx plus c, so then your equation is 2x plus 3. Okay, and we just need to write it out like that. There isn't really any other work we need to do there. With question D, we've got a gradient, negative 3/4, and we've got a point that we're passing through. So anytime we've got a point and a gradient, we're going to use point gradient formula. So y minus y1 equals m bracket x minus x1. So we're going to substitute the values into here. So y minus negative 4 equals to negative 3/4 x minus 1. Now the left-hand side is y plus 4 equals to negative 3 over 4 x minus 1. What we can then do is expand the 3/4 through. So y plus 4 equals to negative 3/4 x plus 3/4. And then we're going to subtract the 4 across. So then we've got just y left on the left-hand side equals negative 3/4 x minus 13 over 4. So that would be the equation in gradient intercept form. Now, like what I said before, what we can also do is we can use the general form. So general form. So just a reminder, that was ax plus by plus c equals 0. So that's what we want to be using. So what we're going to do is here, rather than expanding that bracket, what we're going to do, y plus 4 equals negative 3 over 4 x minus 1. What we're going to do is we're going to take that 4 in the denominator and multiply it across to the left-hand side. So when we multiply it across, we get rid of all of those fractions. So we've got y plus 4 equals to negative 3 x minus 1, and then we'll expand both of those brackets. 4y plus 16 equals negative 3x plus 1. Now we want to keep x positive, and you can see at the moment it's got a negative on it. So we're going to move the 3 to the left, and we'll also subtract, oh, it's not 1, it's 3. We're going to subtract that 3 as well. So then if I add 3x across, so 3x plus 4y plus 13 equals to 0. So that's the other way that we can write out our equation. So both of these are correct. Okay, so you can either write it like this, or you could write it like this. I think the back of the book probably uses the gradient intercept form a little bit more, but it is possible that the solution will be given in general form for you. Okay, last example. Here I've given you 2 points, and we want to find the equation of the line passing through them. So in order to work this out, we're going to first work out the gradient, and then we can use the point gradient form in order to work out the equation of the line. So I'm going to make this one x1, y1, x2, y2, because to work out gradient, the formula was y2 minus y1 over x2 minus x1. So when you go to work it out, it's going to be 8 minus 2 over negative 2 minus 5. That's going to be negative 6 over 7. Once we've got the gradient, then we want to put it into the point gradient formula with either of these points. So it doesn't matter which point you choose to use. In the long run, so once you've worked out all your answers, you'll get exactly the same equation. I'm going to pick the 5, 2, only because in the formula I use x1 and y1. Okay, also because the two numbers are positive, then we're less likely to make mistakes when making those substitutions. So y minus y1 equals mx minus x1. So we've got y minus 2 equals minus 6 over 7 x minus 5. I'm going to change this into general form. So I'm going to multiply that 7 over to the left. So 7y minus 14. So both of those terms get multiplied by 7 equals, and then I'm going to take this negative 6 and I'm going to expand it into the right hand side. Minus 6x plus 30. We can see x is negative again, so we're going to take everything on the right hand side and move it towards the left. So we end up with 6x plus 7y minus 44 equals to 0. If you don't like using general form, we can change that to gradient intercept form. So from that step, we're going to do y minus 2 equals minus 6 over 7x plus 30 over 7. Okay, so what I've done is I've expanded that fraction into the bracket, and then we need to add the 2 across. So if I add 2, I've got minus 6 over 7x, 30 over 7 plus 2 becomes plus 44 over 7. So again, either of those solutions are fine. Okay, the back of the book will only give you one of them, but as long as you've written one of those two, then your answer is correct.